Hello students, welcome to Learners Academy. Today we'll study the next part of chapter some basic concepts of chemistry and is a part of physical chemistry. So let us start with our topic today. Today we are having the classification of matter. In the first video, we have already discussed what are the physical classification of matter, that was solid, liquid and gas. Today we'll study the further part of it, which is chemical classification of matter. And chemically matter is classified into two parts, that is pure substance and mixture. The pure substance is further divided into two parts, that is element and compound. However, the mixture subdivided into two parts, that is homogeneous mixture and heterogeneous mixture. On scales, pure substances can deal with the macroscopic scale and mixture deals with the microscopic scale. So now let us start discussing these one by one. So first of all, let us start with mixture. A mixture contains two or more substances present in it in any ratio, which are called its components. In a mixture, we are having substances that may be more than two or two. And there are two types of mixtures, that is homogeneous mixture and heterogeneous mixture. So let us start with homogeneous mixture first of all. That is, the components of homogeneous mixtures mix completely with each other and its composition is uniform throughout. For example, the sugar solution. And in homogeneous mixtures, we are having examples of milk, juice, and tea. These all are homogeneous mixtures because they are showing uniform composition throughout. You cannot separate the particle inside these liquids easily. So these are known as homogeneous mixtures. The next mixture we are having is heterogeneous mixture. In heterogeneous mixtures, the composition is not uniform throughout, and sometimes the different components can be observed, for example, grains and pulses. In case of this, grains and pulses can be seen with bare eye easily. And in examples, we are having the grains, the nuts, and the grains. And for example, if we take eatable like pizza, over pizza the topping is clearly visible. They are not uniformly mixed with each other, so they can be considered as heterogeneous mixture. So these are some examples of homogeneous mixture and heterogeneous mixtures. So that's all about mixture. Now next we are having is pure substances. In pure substances, the pure substances may be defined as a single substance which cannot be separated by simple physical methods. Like for an example, if you take any pure substance that is in its own form, you cannot break it into any other form because it's having its own shape, its own color, its own physical property. That is called pure substance. And in pure substance, we are having its two types, that is elements and compounds. Elements, the pure substances consisting of one type of particle in the form of atoms, these are known as elements. For example, copper, sodium, iron, or molecules can be taken as hydrogen gas or oxygen gas, etc. If I say about compound, pure substances consisting of molecules formed by the combination of atoms of different elements, like carbon dioxide, which is a combination of two molecules of oxygen and one molecule of carbon. Similarly, water, two molecules of hydrogen and one molecule of oxygen. These are known as compounds. So these are pure substances. Now, properties of matter. What are the properties of matter? We are having two properties of matter, that is physical property and second is chemical property. Let us discuss what is physical property. Those properties which can be measured or observed without changing the identity or composition of the substance. For example, color, odor, melting point, boiling point, etc. If I say about color, you guys all have seen turmeric. It is yellow in color and which is its own identification color. And if I say about odor, let us take the example of garlic. The smell of garlic is itself its identity. You cannot change it. Similarly, some substances having high melting point, because of that they are used in various purposes. If I take the example of tungsten, tungsten is a kind of substance with having high melting point, and because of that, that is used in the filament of a bulb, and because of the high resistivity as well. So these are the some examples of physical properties. Now, chemical properties. It requires a chemical change to occur. If we want to measure the chemical properties, we need to change it chemically. For example, chemical properties are characteristic reactions of different substances, and these includes acidity, basicity, combustibility, etc. Acidity, basicity, and combustibility, these all deals with matter and their change in property with respect to any chemical change. So these are known as the properties of matter. Now let's move to the other topic, that is units of measurement. Now these matters can be measured in various ways. First of all, we are having two units. Actually, we are having three units. First is fundamental unit, second is SI unit, and third system we are having derived units. So first of all, we'll study the fundamental units. The quantities like mass, length, and time. These are called fundamental quantities, and their units are known as fundamental units. Because in the universe, the things around us, we all are having mass, they're having certain length, and they deals with the time. So these are the basic units, that is why it's known as fundamental unit. And the units which represents its fundamental quantity of like mass, length, time, we consider meter, kg, second. These units are known as fundamental units. Now the SI system. The system of measurement is the most common system employed throughout the world. This is the very common system of measurement which is used in all around the world, which is same. And now we are having some quantities, their name of unit and abbreviation. For example, the mass. Mass, we take the unit of mass as kilogram and the abbreviation for this is kg. Similarly, length. Length is also fundamental unit and its name of unit is meter. We measure length in meters, like 52 kilometers of a distance of a particular place to any other place. And its abbreviation is m, small m, meter. The temperature unit is Kelvin, and we represent it as K, the abbreviation. Similarly, the amount of substance is always taken in mole, and the abbreviation for this is mol. And for time, we take the unit second, and the abbreviation for this is S. Similarly, for electric current, ampere, and abbreviation is A, and luminous intensity is candela, that is CD. So that's all about the units of measurement, that is SI system. The next we are having is derived units. Derived units are the units which we use to derive certain other units. Like we take fundamental units and from there we express some functions which represents derived units. And in this some quantities are expressed as a function of more than one fundamental unit known as derived unit. That for example velocity, acceleration, work, energy. For example, if I take about speed, that speed is equal to distance upon time. The formula of speed is distance upon time. And in this, if we want to find the unit of speed, then we have to write speed is equal to distance upon time, and distance we measure in meter and time we measure in second. So if we get it, we use two fundamental units or maybe more than two for other purposes also. So we derive units by using main fundamental units, the 7 main fundamental units which we have discussed in SI system. So we use those 7 fundamental units to derive other units. That is why they are known as derived units. And in this we are having velocity, that is meter per second, because velocity's formula is distance upon time. Similarly, area deals with the side square, that is square meter. Similarly, volume, density, energy, force, frequency, pressure, and electric charge. These all are derived units because in this we use two or more than one fundamental units to derive these units. So these are the derived units. Next we are having is measurement. And measurement of temperature, we are having three scales of temperature, that is Kelvin scale, degree Celsius scale, and degree Fahrenheit scale. And the relationship between scale is 0 degree Fahrenheit is equal to 9 by 5 of degree Celsius plus 32. Similarly, if we want to change Kelvin into degree Celsius, then we have to add degree Celsius plus 273, then we can get 1 Kelvin. Also, 0 degree Kelvin temperature is known as the absolute zero temperature. So these are the measurements of temperature. And here is one example of Fahrenheit thermometer. And here it's representing that at 32 degree Fahrenheit water will freeze, and 68 degree Fahrenheit is the room temperature, is the basic room temperature, and at 212 degree Fahrenheit water starts boiling. And I have taken only one examples of Fahrenheit thermometer over here. And if we want to convert it into Kelvin and degree Celsius, then it will be easily convertible by applying the rule, that is the relationship between the scales. So this is the measurement scale for the temperature. Now the next topic we are having significant figures. The significant figures are meaningful digits which are known with certainty, and these are the digits who can be found by applying certain rules and certain numbers. So let us start. The first rule of significant figures determination is all non-zero digits are significant. How? For example, in 285 centimeter, there are three significant figures because there are three non-zero digits, that is 2, 8 and 5. Similarly, in 0.25 milliliter, there are only two significant figures because there are only two non-zero digits. And the next point we are having here is zeros preceding 2. First non-zero digits are not significant. How? Let us take example. For example, there is 0.03 has one significant figure because zeros are preceding first non-zero digit. That is why it is considered only one significant figure. Similarly, in case of 0.0052, there are only two significant figures. So this is the second rule, that if zeros are preceding the first non-zero digit, that cannot be considered as significant. Now the next we are having is zeros between two non-zero digits are significant. Like for an example, we are having example 2.005 has four significant figures because the two zeros between the two non-zero digits are placed. That is why it all are considered as the significant figures. The fourth rule we are having is zeros at the end of right of a number are significant provided that they are on the right side of decimal point. So this rule has a specific point, that is the zeros can be considered significant if they are following non-zero number, as well as they should be placed after the decimal point. So in the example, 0.200 has three significant figures, which is very clear. Now the next point you are having is counting number of objects. For example, 2 balls or 20 eggs have infinite figures, as these are exact numbers and can be represented by writing infinite number of zeros after placing a decimal, like 2.00000. We can write it as this, and similarly 20x point this can be infinite. If we do not place decimal after 2, then that will be considered infinite significant figures. So we have to place a decimal after that, so to represent only 2 and only 20. So that's the fifth rule. Now what is the addition and subtraction of significant figure? In addition or subtraction of the numbers having different precisions, the final result should be reported to the same number of the decimal places as in the term having the least number of decimal places. How? For example, let us carry out the addition of three numbers, that is 3.52, 2.3 and 6.24. These are having different positions of different number of decimals. Like in 3.52, the decimal is placed before two non-zero digits, and in 2.3 there are only two non-zero digits, and in between them there is decimal placed. So in this case we have to add it by like this. We have to place the decimal, and the addition should be like this, that 3.52, and below this the decimal number should be placed like this, that 4 plus 2 is 6, 5 3 8 2 10. Here goes 0 and 1 carries over there, and 6 2 8 and 8 3 11 plus 1 carry, that becomes 12.06. So this is about the addition. Similarly, if we want to do subtraction, in the subtraction the same rule implies, like we have to place the decimal numbers at below the decimal numbers. So it's all about addition and subtraction. In case of multiplication and division, in multiplication or division, the final result should be reported up to the same number of significant figures as present in the least precise number. Like in multiplication, we take it as 2.2120 into 0.011. That is, we can multiply the numbers. After that, we can place the number of points where decimals are placed. For example, in case of 2.2120, there are four places after decimal, and in the other there are three places after decimal. So we can count it as 4 plus 3 7. So before 7 non-zero digits, before number 7 numbers, we can place the decimal. But according to final results, we can take it as this, like 0.024. And in case of division of numbers, we can divide it like this, and we can correct it by taking the number like this. We are having the final result, that if we divide 4.2211 by 3.76, then we get the 1.12263 result, but the correct answer should be this, because here we have to take the least precise number, because whenever after decimal is there any digit repeating, then we have to take the number till that particular digit. Like in multiplication example, we are having 0.024332. After 3, the 3 is repeating itself again. So for this, we can take the precise number, that should be 0.024. We can take it like this. And similarly in case of the division. So this is all about the multiplication and division. Now, what is dimensional analysis? In dimensional analysis, the derived units first expressed in dimension and each fundamental quantities like mass, length, time are converted in other system of desired unit to work out conversion factor. And that can be represented as this. First of all, we can take the original quantity and multiply it by conversion factor and we get the equivalent quantity. So this is the formula of dimensional analysis. For example, if we are taking the original quantity, that is 1 kg of a particular quantity, and we want to convert it into gram, then we have to place a conversion factor, that is this. For example, if we want to convert 1 kg into 1000 grams, then we have to divide it by 1000, so we can get the result. Similarly, if we convert 1 kg into pound, here in the example we are taking the 1 kg into pound, the equivalent factor we are taking 1. So this is known as the dimensional analysis. Actually, dimensional analysis is taken as the derived units. Firstly, we take the derived units that we obtain by taking the fundamental units, and we are taking their dimensions, and after taking the dimensions we change the units. For example, if a person says you to convert 1 kg into grams, then what we need to do, that we have to take the original quantity and we can divide it by the quantity we want to convert it, and we'll place the number, replace the ratio of the number by taking is equal to 1. So by this method we can easily solve the problem, we can easily convert the number, and dimensional analysis is very useful to convert one quantity into another equivalent quantity. So this is all about today's lecture. I hope you liked the lecture. Kindly subscribe to our YouTube channel, and you can also follow us on Facebook, LinkedIn and Instagram. Thanks for watching the video. Good luck.